There's the saying, blind bat, but no healthy bat is blind. All species can see. My name is Rolf Mueller, and I build bat robots. Bats are special because they combine sensing the environment with a very unusual sense, sonar, with a very high mobility powered flapping flight. Sonar is this idea that you emit an ultrasonic pulse and you listen to the echoes. It has been used in engineering for a long time, particularly underwater, but there's very few alternatives to using sound because electromagnetic waves such as light and radio waves, they do not propagate well. However, bats have taken this to a completely different level. Right? They can thrive in very complicated environments just by listening. And so that's what we would like to reproduce. So the way we study this is that we are trying to get a really fat data pipeline. We record the flight of the bats with an array of 50 high-speed video cameras, and we record the sonar operation with an array of 35 ultrasonic microphones. The idea is to enable automation of tasks in natural outdoor environments. Not all critical tasks for the survival of humanity can be carried out on factory floors and in warehouses. The ecosystems that sustain you, they are not in the flower pot on your windowsill, they are somewhere outdoors and they are under pressure. There's species loss, there's pollution, there's garbage. If we want to get on top of these issues, we really need automation. So you have a row of blueberry bushes, right? If you have to go in there and see how the blueberries are doing, which the farmer definitely wants to do, you are in a little jungle and you have to move in that. Right? And so these are some of the applications. What is cool about the bat, and I think the breakthrough we are looking for in engineering, is to have a robot that can sense its environment with sonar and then maneuver through it with flapping flight. The bats can do that, but we can't. Right? So what I have in mind is eventually we will cross our two lines of bat robots so that it can have offsprings that have sonar and flight. There's the saying, blind bat, but no healthy bat is blind. All species can see. There's about 1,400 species of bats in the world, out of which about 1,200 use sonar, and then the remaining 200, they rely exclusively on vision. Bats account for a bit more than 20% of all mammalian species. They're the second most species-rich group after rodents. This combination of sonar sensing, it means you can sense whether the light is on or the light is off. And with powered flight, which means you can go anywhere you want in 3D, right? You can go left, you can go right, but you can also go up and you can go down. And so look at what is actually the ecological diversity, what can bats do? And that's where they are probably number one. That's what I find really fascinating about these animals, and that's something I would also like to be able to do in engineering, right? Take a simple principle, you listen to echoes, you flap your wings, and you adopt that to all these different uses. That would be really cool if we could do that too. My name is Rolf Mueller. I'm a professor in the Department of Mechanical Engineering at Virginia Tech.